Hey guys, this lesson is about how to apply the rules to coordinates. So all of the other lessons that I've posted are about how to reflect, how to graph the reflection. This is just if you are struggling with understanding what the rules are doing, this is going to help you understand how to apply the transformation rule. And it kind of goes through each type of reflection and translation and rotation to kind of break it down and help you understand how to actually apply the rule. So let's get started. This rule, x comma negative y, this is an x-axis reflection. So this is the rule if I want to flip over the x-axis. We have a positive x and a change in y. The best way to do these problems is to just pay attention to this top part. So notice here we start with xy and the change is x comma negative y. What this means is my x values all stay the same because there's no negative in front of x. So whatever x started as, it's going to stay because there is no change. Now as far as the y values go, there is a symbol in front of that. There's a negative sign. So what that means is my y value gets a sign change. It doesn't mean make it negative, it just means change the sign. So the 5, when I plug 5 in for y, becomes negative 5. So my new point is 3, negative 5. Let's try the next one. Again, positive 3 goes in for x, positive 3 comes out for x because there's no change. Now on the negative, this is going to change a little bit because I already have a negative 5. So when I plug the negative 5 in for negative y, that makes it become a positive. And lastly, we have a negative 5 for x, and there is no change here, so it's going to stay a negative 5. And again, we're plugging in a negative 3 for y, and if there's already that sign change out here, that means it's going to become positive. And that's all you have to do. Notice how these x values that are listed here, there is no change in them. So it's like we just copy and paste it. The only thing that happens here is the y's change sign. So instead of 5, we get a negative 5, and so on. This next rule is negative x comma y. This is a y-axis reflection. So this is us reflecting over the y-axis. In this rule, what happens is the x values are now the ones that change because notice the negative in front. So all of these x values stay listed first, but they all change sign. So 3 becomes negative 3. Now y is the easy part. On this one, y is just y. So this is just going to stay a 5. Okay. Plugging in negative, if I want to sign change the negative, the opposite of negative 3 is positive 3. And again, my y stays the same because there's no change. All right, we got a negative 6, and I want to change its sign. The opposite of negative 6 is positive 6. And my 7 gets no sign change. So notice in this type of reflection, my y value has got nothing happening. So that means on my side over here, my y values should all be the same, but my x's should have changed sign. All right, on this one, this is a little bit different. Notice how there's no negatives in these problems. That means that we're going to keep the signs the same. But now what's going to happen is locations are going to flip-flop. This was xy and is now yx. This is a y equals x reflection. Okay. So what this means is my x values started out front, but they're going to become the new y values. So my 5 started here, it moves to the end. The negative 7 started here, and now that y is going to just move to the front. So notice how they flip-flop. Nothing else is changing. Sign changes are not happening. It's just location changes because my rule is yx. So on here, the negative 10 moves to the end. The positive 3 moves to the front. Negative 12 moves to the end. Negative 16 moves to the front. Notice here, all that's happening is a location change. X was first, X is now last. Nothing happened, identical, all we did was move them. Y was last, Y is now first. The math is the same, all that's happened is they flipped location. Alright, negative Y, negative X. On this type of rule, this is a reflection over the line Y equals negative X. This one is, I think, one of the more challenging ones because two things happen. X and Y flip, because notice how it's XY, then YX, and they have sign changes. So X and Y are changing location and they're becoming the opposite sign. So my X values move to the end and change. So 6 becomes negative 6. The 7 moves to the front and changes. Negative 7. All right, negative 3 moves to the end and it changes to a positive 3. Negative 4 moves to the front, and that negative means change, so we're going to change it to positive 4. Negative 3 moves to the end and becomes positive. The 4 moves to the front and changes. So if you pay attention to X, Y, and your rule, you'll be able to see what's happening. X and Y are just numbers, so you're applying the rules to some numbers. That kind of takes care of all of our reflections, so let's go ahead and do some rotation rules real quick. Negative Y, comma, X. Negative Y, comma, X, this rule is a counterclockwise 90 or a clockwise 270 rule. They're the same rule, remember, it just depends on the direction. So on this one is a little tricky because what ends up happening is my X values move to the end, but they're not changing. So 6 is going to stay 6. However, my Y value moves to the front and does change. So I get negative 3. The opposite of that is positive 3. Down here, negative 4 just moves to the end. There's no sign change because it stays X. My 3 moves to the front and it changes sign. Negative 4 moves to the end, no change. Negative 5 moves to the front and it does change. So notice in this problem, the changes occur only for Y. The X values, all they do is they just move. There is no sign change, they're the same numbers. All that happens is they just move to the end. Now with the Y's, they do change sign and they move location. All right, negative X, negative Y. This is a counterclockwise 180 degree rotation or a clockwise 180 degree rotation. Remember, they're the same. So it doesn't matter what direction you go. 180 is that special one that's the same both directions. All right, so let's go ahead and apply this rule. X and Y stay put. Notice how X and Y are still first and second. The only thing that changes now is the sign. We started with the negative, or we started with just X, so it became negative X. Started with Y, it became negative Y. Location is staying the same. So my 9 is still going to be first, but now there's a sign change. So this becomes negative 9. For my Y value stays put, but it changes from a negative 10 to a positive 10 because of that negative sign. Remember, it's a sign change, so if it's already negative, make it positive. Negative 3 is my X value. It's going to stay put, but it's going to change to positive because it's a sign change problem. Y, same thing. It stays second, but it's got to change sign. Lastly, we have negative 10. That opposite of that is positive 10. And then my Y value, my sign change of negative 12, becomes positive 12. Our last rule as far as rotations go is y comma negative x. So for y comma negative x, this is a rotation counterclockwise 270 or clockwise 90 degrees. Remember, they're the same rule, just opposite directions of each other. On this problem, my y values are the ones that are staying the same. All those y values, they're going to just move to the front now. Okay. So all these y values are just going to move to the front. My x values are the ones that are moving. So it started as a positive 7. It's going to move to the end and become negative 7. My negative 2 for my y moves to the front. Negative 2. There's no change. It just moves. For the negative 3x over here, it's going to move to the end and change because it's got that minus. Remember, it doesn't mean make it minus. It means change the sign. And then my 6 moves to the front, stays the same. Lastly, we've got negative 3. That's just moving on to the end. And I'm going to change its sign, so that should be a positive 3. And then my negative 10 moves to the front and stays the same. And those are all of your rotation rules. And let's go ahead and just make sure that we're okay as far as translations. So in a translation, that is a slide. This is called point notation. Remember, we can change this from component form, which would be 7 comma negative 2. Component form gets those pointed little brackets instead of parentheses. So remember, point, parentheses, they both start with P. That's the best way to kind of remember it. This is now just a function. You're going to take all those x values and you're going to just add 7 to them. All x values are plus 7. So 6 plus 7 is 13. 3 plus 7 is 10. Negative 5 plus 7 is 2. And I like to kind of do these vertically, just kind of go through all your x's first, and then it's a little easier to transition into your y's. So now all of your y values, you're going to subtract 2. 2 minus 2 is 0. Negative 7 minus 2 is negative 9. And 2 minus 2 is 0. So these are just basic addition and subtraction. Down here, this is another type of translation. Notice how we don't have plus a number here. That's a component form of 0 comma negative 3. We just don't write plus 0. It's just something that's not needed. So we just leave it as x if we're going to write it in point notation. The easy part here is if I'm adding nothing, that means these x values don't change. They're going to stay the same. So I'm going to be left with 7 and negative 3 for my x's because they're not going to change at all. However, all of my y values, I have to subtract 3. So 2 minus 3 is negative 1. Negative 3 minus 3 is negative 6. So translations are easier. They're just addition and subtraction.